Welcome back my dear friends. A very good morning, good afternoon, good evening to all of you. This is the data analysis and decision making 1 course under NPTEL MOOC, and as you know this is a 12-week course and that is 60 lectures which is of 30 hours total combined, and each week we have 5 lectures, each being of half an hour. So, we have completed the middle almost till 30 lectures. We are going to start the 32nd one today. So, if you remember, we are discussing about after almost at the fag end of 29th or 29th, we started basically the multivariate statistical methods, and we discussed that what was basically definition wise, what was the mean, the standard deviation of the population or the variance of the population, and that can be the second part can basically be portrayed or given the information as the covariance variance matrix, which is a P cross P or K cross K matrix, where P and K are the number of independent variables and the mean are basically given by a vector mu P, size being P cross 1. The first element, as obviously you know, is the number of rows and second being the number of columns. Then the corresponding sample mean would be x bar P. So, these mu, this covariance variance matrix, which is summation symbol, or the x bar P, all are bold, either matrix or vectors. Then the corresponding part for the variance covariance matrix would be the capital S, which is the standard error square values. Then you have the correlation coefficient, the counterpart in the case which is also P cross P or K cross K matrix, and the counterpart in the sample would be capital R. All are bold, S is bold, R is bold, rho is bold, then R is bold. Then we considered the multinomial model, and that is basically the, as I mentioned, the polynomial expansion, multinomial expansion, the parameter, the coefficients would be exactly be as discussed in the multinomial model. And we also discussed using the Pascal's triangle how the slices which you take basically depicts the parameters, the coefficients. So, we will continue further on with the multinomial distribution. So, consider these are actual data. So, based on the data we are trying to basically give you a picture. So, they till now for the multinomial they would has not been any problem. Problem means solved examples. We are just given examples and trying to give it in a pictorial format. So, consider the use of contraceptive amongst married women in El Salvador in the year 1985, and the data for the same is basically there for a sample of 3165. These are all actual data taken from the net, and the respondents gave their responses accordingly. So, in the first column you have the age. So, for the first group is 15 to 19, then 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, 45 to 49. The second one, basically second, third and fourth one are the respective set of women in that age category who use contraceptive methods, sterilization, or they use other methods or they use none. So, obviously to give an example, if you consider the age bracket 35 to 39, the corresponding values of number of women who use sterilization method, other methods and none is basically 197, 50 and 188, and correspondingly the values are given for each age bracket, and the last column is basically the summation of all the number of women for each age category. So, say for example, for the age category 20 to 24, the total number is 617. So, you have these numbers, and also have a look at the last row which gives you in each category the total number of women irrespective of the age bracket. For sterilization is 1005, for other method is 489, and for none using any contraceptive method is 1671. So, you will basically try to use this data for the multinomial model. Now consider x1, x2, x3 as the random variables signifying the three variables or the information, which is the case of sterilization, which is use of other method and using none of the methods. So, obviously, this x1, x2, x3 would is the random variable which will depict that depending on the age. Now, but I am basically considering all of them together, age is not a factor now. So, then the joint multinomial distribution, this is basically of three variables, trinomial distribution may be written. So, this capital, so technically these values, so this is basically f capital X1, X2, X3, X1, X2, X3. So, this is basically the PMF value. Actually, it means what it actually means is this. That means, when capital X1, which is the random variable, takes the realized value of small x1, capital X2 takes the realized value of small x2, and capital X3 takes the realized value of small x3. Then the multinomial distribution is given like this. So, again I use the red color. So, is NC x1, x2, x3. So, obviously, that will be factorial n divided by factorial x1, factorial x2, factorial x3 and so on and so forth. So, obviously, remember this is important. And the corresponding formula which you had was, these were the coefficients. So, the probabilities would be P1, x1, P2, x2, P3, x3. So, now if I ask you the question what is P1 or P2 or P3, and you will rightly mention that. So, P1 would basically be, so I will take this. So, P1 would be the number of women who are using sterilization, because x1 corresponds to that number of people, women who are using sterilization with respect to the total number of women who have been the respondents. So, that would obviously be 316165 is the total number. So, it will be 1005 divided by 3165. Similarly, for P2 it will be the number of the ratios or the relative frequency or the chance of the number of women who are using other methods divided by the total number, which is again 489 divided by 3165. And the last value would be corresponding to number of number for the women who are using none of the methods, no sterilization methods. So, that number is relative frequency is 1005 divided by 3165. So, based on that you can find out these values the moment you put x1, x2, x3. Obviously, you should remember this. So, I will just underline it. So, the sum of x1, x2, x3 is equal to n. So, you put it and solve the problems accordingly. Now, here I have basically consider the trinomial distribution. So, in this case, and obviously remember, because x1 and x2 if they are given, x3 is immediately known because the sum is always n. So, I plot sterilization along the x axis. So, I am just marking it, other means along, say for example, the y axis, and basically if I consider the probability mass function for the trinomial distribution considering some values of x1, x2, x3. So, I keep changing, probabilities are fixed, remember P1, P2, P3 are fixed. So, I keep changing x1, x2, x3 based on the fact that the sum of x1, x2, x3 is equal to n, change those values, plot them. So, consider here is x1 and consider here is x2. So, the value would be somewhere here. So, and obviously, in that case x3 is already known because x3 would be n minus x1 minus x2. Similarly, if I consider this 5 value for x2, take it along the x axis, I take along say for example 5 for x1 along this axis where they meet, this height would be the corresponding PMF, because immediately x1 x2 being known, you have x3 because the sum is n. Sum means x1 plus x2 plus x3. So, there are very simple codes you can utilize in MATLAB or R or whatever, and you will get the informations accordingly. Now, we considered the multinomial multivariate normal distribution. So, of p number of variables or k number of variables. So, we say x suffix p, p mean the number of independent variables. P is now normally distributed with the mean value of mu. So, this is bold, remember, and the variance covariance matrix being given. So, we will say this is a multivariate normal distribution, and the form would be this is the PDF value. So, f x1 to xn, and this actually means the corresponding realized values for the random variable x1 to xp. So, that would be given by the following distribution, and remember, so this is a very simple case. If you remember, the formula looks ominous, threatening, but it is not, because if you do a one-to-one comparison with the univariate case, the information comes out very easily. So, in the univariate case, what you had? You had 1 by 2 pi. So, obviously, here this 2 is corresponding to square root, which is here. Now, why p? Because there are such p number of random variables. So, obviously, p would come because you are multiplying the corresponding probabilities of the PDFs. Now, you had 1 by sigma, which was the standard deviation. So, in this case, sigma would be replaced by the corresponding variance covariance matrix. So, technically I could have written this as, let me erase it. So, look at this. Oh no, I should write it. Sure, this should not be. It is not the way how I want it to be. So, it is 1 by sigma. So, sigma goes up, it becomes minus, and y, so minus. So, now if I do it square, so obviously it will be 2. So, in this case I write it as this part only as 1 by 2 pi sigma square to the power minus half, and this we will see again a one-to-one correspondence. Sigma square is what? Sigma square is the variance covariance so called value, with this in the univariate case is a one value only. Now, if there are two random variables, so the principal diagonal will be the first one, 1 comma 1 would be the covariance of the first, which with itself, which is the variance of the first. The 2 comma 2 would be the covariance of the second with itself, which is sigma square to the power 2, or sigma base 2 to the power 2, because that is the variance of the second. And the off the diagonal element would be sigma 1 2, so that means 1 2 number is in the suffix, and sigma 2 1, and they being symmetric. So, in this case you have the variance covariance matrix. So, that is here mod of that, because you have to consider this positive definite, and to the power half, because you are taking it to the numerator, hence half here, divided by 2 because you are taking the square root. So, I will use the highlighter first for the brown. So, this part has some oh my god, so sorry, the color obviously was couldn't be red. So, I will use a lighter color, hopefully it will be possible. Yes. So, this is what I have for this case. Then I try to basically have a set of information here which matches here. Now, in the case of the univariate, so later on you had e to the power minus x minus mu whole square by 2 sigma square. So, this was the total formula. So, e to the power is here. So, I will try to utilize the color again. Let me check one color. Let me use the light green. Yes. So, here again you will have e to the power. So, this becomes, this is sigma square. Sigma square is what? So, sigma square, this 2 is coming here with a minus sign. The sigma square is basically, I should try to use colors, so it is easy for you to understand. So, let me use dark blue if possible, if it is not too problematic. I am just dotting it, so it does not get problematic. So, this is this part. Now, finally, let me check any other color. Orange is there, yes. So, this is x minus the square value. So, this is the random value minus mean value. This is this. Because why this is a transpose, x minus mu transpose is x minus mu, because they are vectors. So, obviously, you have to take the values accordingly. So, this x is basically the random variables corresponding to the first, second, third, fourth, so on and so forth. Now, as usual, you will have x values ranging from minus infinity to plus infinity. Expected value of x is mu, covariance of x is the variance covariance matrix, and the fact that the covariance variance matrix would always be positive definite. So, I will basically erase this and highlight the important facts. So, this is the covariance of the first with itself, which is the variance. Similarly, covariance of second with itself, with its 2 comma 2 element, till the last one, which is the covariance of pth one with itself, which is the variance of the pth random variable, and the off the diagonal element, the sigma 1 p suffix 1 p, which is the covariance of first with p, is equal to the covariance of pth to the 1. So, this is a symmetric matrix. An interesting and important concept in multinomial normal distribution is sometimes to do with circles and ellipses. So, to which degrees they are dependent. Consider p is now 2. So, in this in case is p is 2, so obviously it will be given by this formula. This is a set formula, you can just expand whatever are given. So, again 2 pi comes, the square root comes, exponential comes, outside minus 1 by 2 is there, this square whole square. So, if you expand it x1 minus mu 1, that matrix into x1 minus x2 into minus mu 2, that matrix if you multiply. So, what I mean is this. So, in this case you have x minus mu transpose x minus mu. So, here x is of size 2 cross 1, similarly you will have this 2 cross 1 and you continue doing it and find out the value. So, this is the formula given. Now, the case is that we want to basically have the counters coming out in the picture. So, if in counters mean the relationship. So, if I am considering the relationship of the first variable and the second variable and I take slices of. So, multinomial bivariate normal distribution would look like a hillock, symmetric hillock, and if both of them are their correlation coefficients is 0. So, it will be a, if you take slices, it would be a circle. and if they are positive related, correlated, negative correlated, they would be then in the first and the fourth, or the second and the first and the third and the second and the fourth quadrant. So, this is what is being highlighted. So, if I have the bivariate normal distribution, rho 1 2 or rho 2 1 is 0. So, they are symmetric, and if the hillock means basically you are looking from the top view. So, the concentric circles would be there, more concentration of the values on the data point near the central line, if you basically put a vertical line down from where I am looking. So, the points are concentrated, and but in general the relationship between random variable 1 and random variable 2 would be such that the correlation coefficient does not exist. If it does not exist, obviously it means the covariance variance matrix would have only the principal diagonals, of the diagonal elements are not there because the values are technically 0, but obviously variance of first, variance of second would remain. Similarly, the counter would look for the case when the positive negative correlations are considered accordingly. So, obviously you can imagine in a 3 dimension, 4 dimension, 5 dimension, they would be spheres, hyperspheres, ellipse, hyperellipse and so on. And so, these are ellipses with a major and minor axis accordingly, and they would be ellipses. You can basically visualize how they would basically look like. Is this slice is, say for example, you are considering the game of rugby. So, this is an elongated ball. So, if you take slices, principal diagonal, principal axis and the major axis and minor axis, major axis would be the one for which the variance is higher, minor axis being the case where the variance is low, and it can be reversed. Major becomes minor, minor becomes major. Now, if you remember, we have considered the t distribution, and that was for the univariate case. So, the t distribution which we will consider now is the joint probability distribution function for the multivariate student t, and the standard form is given by the same formula, but we are just extending it to the multivariate case. So, here we will consider this value of so called V is the degrees of freedom. So, in there you had n. So, these degrees of freedom, and where y has V degrees of freedom is a univariate t distribution, and each of them are univariate, y1, y2, y3 are univariate t distributions, and you remember that how we have obtained the t distribution. So, you can basically normalize them. So, you are normalizing xi or xj, which is the standard normal, divided by the s, which is the standard error, that s dash and s concept, divided by the square root of the degrees of freedom. And this is the, which if you remember, this s dash and s. So, let me highlight, yes. So, this n minus 1 is coming, these values are there. So, here the population mean is not known. So, here remember x1 to xp have a joint standard multi-normal distribution. So, x1 is normal, x2 is normal, x3 is normal till xp is normal. So, once you combine them, you will find out that they are normal distribution. We will, for a multi-normal distribution, we will consider here in such a case that the expected values of x is 0 in the standard case, because it is a standard multinomial distribution. Obviously, the mean value would be 0 and the variance would obviously, remember, for each would be 1, and corresponding to the fact you will have the variance covariance matrix depending on the correlation for each and every element, I to j, j to I, all these things. The covariance of x would be given by the matrix R, which is the correlation coefficient matrix, and in this case you will find out S, not S dash or S star, because in that case the mean values are known, in this case the mean values are not known. So, you will use S without the dash, and that would basically be, so this should be square, my apologies, should be square. So, that will be 1 by n minus 1 depending on the degrees of freedom. summation of all the squared values of the difference between the realized values and the mean value. Now, we will discuss something to do with the copula function, and here I will again come back to the copula function later on. So, let me give you a very brief background, even though statistically it may not be adequate considering the whole set of information I would like to pass it on to you. So, consider the covariance. So, in the covariance function, if you consider, the covariance function actually looks like this. Basically, the expected value of the multiplication of the differences between x and its mean values and y in its mean values. Now, consider that if you consider this is a sort of linear relationship, but consider that at the extremes, either for a normal distribution or any other distribution, the relationship is such that per unit change in x or per unit change in y, the rate of change of the value of the other random variable is happening at a faster rate, which is not linear anymore. But if you consider the covariance concept, we consider that whatever the values of x's are, if it changes by 1 unit, then the y value would change correspondingly or proportionally. And the statement also remains true for the other case, when y is at any extreme high values or very low values. It need not be very high positive, it can be very low negative also. So, as y changes or x changes, the rate of change of the corresponding other random variables are not linear. So, in order to basically map the relationship between x and y at the extremes, we use the copula function. Copula function is basically a sort of linkages, a chain linkages, which basically gives you the relationship between x and y. So, copula function is given by C, and this u1 to up are the univariate case. Why they are univariate, I am going to come to that later. So, C is a function of univariate numbers of distribution u1 to up, and it is basically a multivariate probability distribution. Copula by itself is a probability function, for which the marginal probabilities are given in such a way that j is equal to 1, 2, 3, 4 till p, because your p variables would be uniform. That means, each of the u's are between 0 and 1. Combining them, we find out a copula function, which is a function of u1 to up, such that we are able to map or have a linkage between the random variables x and y, such that the extreme of the higher values, the relationship between x and y are given, which are much true in nature than with respect to the covariance variance matrix relationship, which is linear in nature. With this, I will end the 32nd class and continue further discussion on the multivariate distributions. And for any queries, please feel free to write to on the forum, and we will definitely answer it as soon as possible with whatever information is needed. And once again I am telling you, because this I will be repeating time and again, especially for the later part after the 30th lecture, which is to do with multivariate statistical methods, that read the books. Books are absolutely plenty in the market, plenty in the net. So, the set of books which we have suggested are more from a conceptual point clearing, and obviously people can, after doing that, it will be much easier for them to pick up any data set, pick up any data set oriented book in multivariate statistics and read them and do the problems accordingly. With this I will end the class. Have a nice day and thank you very much.